Definition of derivatives. So now, my only goal here is to find the slope of the tangent line at A. So I have an example. So this graph, I have example of a point A. So what is a tangent line? So a tangent line is a line that comes down and only touches the curved line. So now, I'm gonna add one point in here. So this point is now A plus H or A plus H. So now, what is the second line? So the second line is the line that connects the 2 points in a curve, which is like this. Second line, which is the line that connects 2 points in a curve, point A plus H and point A. So now, I want to show that this point is F equals to A plus H. So now, to find the slope of the second line, is divided into 4 lines. So now, we can conclude that f of A rise to f A plus H. So now, it becomes f A plus H minus f of A. So this is our rise. So now we get the run. So now run from A, point A, to second point, which is A plus H. So now A plus H minus A. So this is how to find the slope of the second line. So it could be f of A plus H minus f of A over H. So now I get my goal to find the slope of the second line.
Show you on how to solve the limit definition of the derivative. The derivative of a function is the function f prime defined by f of x equals to limit of f of x plus h minus f of x all over h as h approaches to 0. So the given is f of x equals 2x squared minus 16x plus 35. So f prime of x equals limit of f of x plus h minus f of x minus h as h approaches to 0 equals to limit of 2 times x plus h squared minus 16 times x plus h plus 35 minus 2x squared minus 16x plus 35 all over h. Limit as 2x squared plus 4xh plus 2h squared minus 16x minus 16h plus 35 minus 2x squared plus 16x minus 35 all over h as h approaches to 0. So we're going to combine the like terms and cancel the like terms. And the result will be limit as 4xh plus 2h squared minus 16 all over h as h approaches to 0.
we have derivative sine x is equals to limit as h approaches to 0. F quantity of x plus h minus f of x all over h is equals to limit as h approaches to 0 sine quantity of x plus h minus sine x all over h. As h approaches to 0, sine times cosine h plus cosine times sine h minus sine x all over h is equals to limit as h approaches to 0, sine x times cosine h minus sine x plus cosine x times sine h all over h. This is equals to limit as h approaches to 0, sine x times the quantity of cosine h minus 1 plus cosine x times sine h all over h. Equals to limit as h approaches to 0, sine x times the quantity of cosine h minus 1 all over h plus limit as h approaches to 0, cosine x times sine h all over h. Sine x times limit of h approaches to 0, 1 minus cosine h all over h plus cosine x limit as h approaches to 0, sine of h all over h. Sine x times 0 plus cosine x times 1. So the final answer is f prime of x is equals to cosine x.
Audio Jungle.
Constant rule. Always remember the derivatives of a constant is equal to 0.
Number 1. Derivatives of 5 is equal to 0 and derivatives of 10 equals to 0.
Power rule.
Note, the derivative of x to the power of n is nx to the power of n minus 1. For example, find the derivative of x squared and the derivative of 1 over x. For x squared, we use the power rule with n equals 2. The derivative of x squared equals 2x to the power of 2 minus 1 equals 2x to the power of 1, which is f prime of x equals 2x. Example number 2, which is derivative of 1 of x. So we should do inverse of 1 of x is also x to the power of negative 1. Using the power rule with n equals negative 1, the derivatives of x to the power of n equals nx to the power of n minus 1 is the derivative of x minus 1 equals negative 1x minus I to the power of negative 1 minus 1 is equals to negative x to the power of negative 2.
Rule number 3, constant time function. The constant multiple rule says that the derivative of a constant multiplied by a function is the constant multiplied by the derivative of the function. For example, find the derivative of negative 5x and positive 3x. We all know if c is a constant, then derivative of c times f of x is equals to c times derivative of f and of x. Here, x has the power of 1. So x raised to the power of 1 is equals to 1. So 1 times negative 5 is equals to negative 5. So the derivative of negative 5x is equals to negative 5.
F prime of x equals derivative of 7x raised to the power of 5 plus derivative of 3x raised to the power of 2 minus derivative of 4x plus derivative 12. So it becomes f prime of x equals to 5 times 7x raised to the power of 5 minus 1 plus 2 times 3x raised to the power of 2 minus 1 minus 1 times 4x raised to the power of 1 minus 1 plus 0. And the final answer is f prime of x equals 35x raised to the power of 4 plus 6x minus 4. Number 2 example. Find the derivative of 5x raised to the power of 3 minus 4x raised to the power of 2. In order to solve this equation, we need to find the derivatives of every function, just like what we did in the first example. The solution is f prime of x equals to derivative of 5x raised to the power of 3 minus derivative of 4x raised to the power of 2. So the derivative of 5x raised to the power of 3 minus 4x raised to the power of 2 is f prime of x equals 15x raised to the power of 2 minus 8x.
Product rule where the function is h of x is equals to f of x times g of x. Its derivative is h prime of x is equals to f of x times g prime of x plus g of x plus f prime of x, or udv plus vdu. The formula of the product rule is h prime of x is equals to f of x times g prime of x plus g of x times f prime of x, or udv plus vdu. So our given example is f of x is equals to quantity of 6x cubed minus x times quantity of 10 minus 20x. So our given for you is 6x cubed minus x. So the derivative for you is du is equals to 18x squared minus 1. 6x cubed minus x times negative 20 plus 10 minus 20x times 18x squared minus 1. Negative 20x cubed plus 20x plus 180x squared minus 30x cubed minus 10 plus 20x. We combine the like terms and that gives us negative 480x cubed plus 180x squared plus 40x minus 10.
f of x equals 2x squared minus 16x plus 35. F prime of x equals limit of f times x plus h minus f of x all over h as h approaches to 0 is equals to limit of 2 times x plus h squared minus 16 times x plus h plus 35 minus the quantity of 2x squared minus 16x plus 35 all over h as h approaches to 0 equals to the limit of 2x squared plus 4xh plus 2h squared minus 16x minus 16h plus 35 minus 2x squared plus 16x minus 35 all over h as h approaches to 0 is equals to limit of 4xh plus 2h squared minus 16h all over h as h approaches to 0. So we're going to factor out its like term, and the result is limit as h times 4x plus 2h minus 16 all over h. So we're going to cancel the h, and the result will be limit of 4x plus 2h minus 16 as h approaches to 0. And we're going to substitute the h into 0, which is the result is 4x minus 16. The final answer is f prime of x equals to 4x minus 16. So the given number 2 is f of x equals 5x minus 2. So f prime of x equals limit of f times x plus h minus f of x all over h as h approaches to 0 is equals to limit of 5 times x plus h minus 2 minus the quantity of 5x minus 2 all over h as h approaches to 0 is equals to limit of 5x plus 5h minus 2 minus 5x plus 2 all over h as h approaches to 0. And we're going to cancel the like terms, and the result is limit of 5h over h as h approaches to 0. So we're going to cancel the h from the given, and the remaining number will be the final answer, which is f of x equals to 5.
derivative is the rate of change of function at a specified point. The derivative other than the first derivative are called the higher point derivative. Given is f of x equals 5x cubed minus 3x squared plus 10x minus 5, then we will find the third derivative. So f prime of x is equals to 15x squared minus 6x plus 10 minus 0. The second derivative is equals to 30x minus 6 plus 0. Then the third and final derivative is equals to 30. Given is f of x equals 2x to the power of 10. Then we will derive this 5 times. So f prime of x is equals to 2 times 10x to the power of 10 minus 1. The second derivative is 2 times 10 times 9x to the power of 9 minus 1. The third derivative is 2 times 10 times 9 times 8x to the power of 8 minus 1. The fourth derivative is equals to 2 times 10 times 9 times 8 times 7x to the power of 7 minus 1. The fifth and final derivative is equals to 2 times 10 times 9 times 8 times 7 times 6x to the power of 6 minus 1. And the fifth derivative is equals to 60,480x to the power of 5.
So chain rule. Chain rule is derivative of the outside function leaving the inside function times derivative of the inside function. If we define f of x is equal to f composed of g of x, then the derivative of f of x is f prime of x is equal to f prime of g of x times g prime of x. So the first example is f of x is equal to the quantity of 3x plus 4 to the power of 5. So f of x is equal to the quantity of 3x plus 4 to the power of 5. So first, we need to get the outside function, which is 5. So next, we'll copy the inside function, which is 3x plus 4 to the power of 5 minus 1. Then next, we need to get the derivative of inside function, which is 3. So next, we will multiply the like terms, which is 5 times 3 equals to 15 to the quantity of 3x plus 4 to the power of 4. So f prime of x is equal to 50 to the quantity of 3x plus 4 to the quantity of to the raised to the power of 4. Second example, f of x is equal to the quantity of 2x plus 3 to the power of 3. So we need to get first the outside function, which is 3. So we will copy the inside function and then the power is minus 1. So the quantity of 2x plus 3 power to the power of 3 minus 1. Then we need to get the derivative of the inside function, which is 2. So next, we'll multiply the like terms. Then f prime of x is equal to 6 times the quantity of 2x plus 3 to the power of 2. So basically, the perimeter is equal to 2x plus 5y. So the parameter is 950. So 950 is equal to 2x plus 5y. So we need to use the subtraction property of equality so that we can get the 950 minus 5y minus 2 is equal to 2x. So we need to divide both sides by 2 so we get the x. So 950 divided by 2 is equal to 475 minus 5y divided by 2 is equal to 2.5y is equal to x. So the area is equal to 475 minus 2.5y times y. So it's equal to, area is equal to 475y minus 2.5y squared. So we need to derive it. 475y minus 2.5y squared is equal to 475 minus 5y. So that's the derive of 475y minus 2.5y squared. So next step, so we need to use addition property of equality. So it's equal to 475 equals to 5y. So we need to divide both sides by 5 to get the y. So 475 divided by 5 is equal to 95. So it could be cancelled. So 95 is equal to y. So we already get the y. So y is equal to 95. So we need to solve for x. So x is equal to 475 minus 2.5y. So y we need to substitute into 95. So x is equal to 475 minus 2.5 times 95. So x is equal to 475 minus 237.5. So basically x is equal to 237.5. So next, we already get the x and y. So next, we need to get the area. To get the area, so area is equal to x times y. So area is equal to 237.5 times 95. So basically, area is equal to 22,562.5 feet. That's all. Thank you. So example number 2. A farmer has 20,000 feet of fencing and wants to create a rectangular field along the river. What is the largest area of the rectangular field? So the parameter is x plus 2y. So the parameter of fence is 20,000 feet. So 20,000 feet is equal to x plus 2y. So we need to use the subtraction property of equality to get this 20,000 feet minus 2y is equal to x. So next is the quantity of 20,000 feet minus 2y times y. So we will get the 20,000 y is equal to 2y squared. So next we need to derive it. So 20,000 minus 4y. So we need to use the division property of equality. So 20,000 divided by 4 is equal to 4y minus divided by 4. So it will be cancelled. So y is equal to 5,000. We already get the y. So y is equal to 5,000. So next, we need to get the x. So x is equal to 20,000 minus 2y. So y, we need to substitute it to 5,000. So x is equal to 20,000 minus 2 times 5,000. So x is equal to 20,000 minus 10,000. So we'll get the x is equal to 10,000 feet. So next, we need to find the area. So area is equal to x times y. So area is equal to 10,000 feet times 5,000 feet. So we will get the area is equal to 50,000 feet squared.